Welcome everybody. Pause the video and read the question carefully. As we can see, the question is asking me to calculate the average bond energy with given data, as we can see here. So how can I arrange all of these data in order to calculate the bond energy? But what type of bond energy? We can see that the product here is BRF3, and actually it looks like this. So we just need to understand and to calculate the average bond energy of BRF. However, if you look at the product at this point, you can see that you have two molecules of BRF3. And we have to say something like really important at this point, which is the average. So you have to put in your mind that at the end of the process, you have to divide over the number of bonds. There is amount of energy that represents the atomization process here to here. We're breaking the bonds between them, and this is the magnitude, and it's ready for me. The second information that is given to me says the standard enthalpy change of formation of BRF3 liquid is equal to negative 301 kilojoule per mole, which is represented in here. But you have to look at something that is really important. You have 2 moles of a product. And if we remember the standard enthalpy change of formation, we should have only one. At this point, this number here must be multiplied by 2 because you have 2 moles of the product. That's why you have to say minus 301 and it's multiplied by 2. And if we complete it again here, let's go to this one here. The other information says the enthalpy change of BRF3 liquid to gas is equal to positive 44 kilojoule per mole, which is in here, as we can see. This is the point. And if we just read it carefully, we can notice that it's 44. But wait again, it is kilojoule per mole, which means each 1 mole contains 44 kilojoule. And at this point, we can see that we have 2 moles of this material. That's why it should be multiplied by 2. Okay, and now my rule here is to calculate this amount. This is the total amount of energy needed to break the 6 bonds. As we can see in here, we have 6 bonds, by the way. So just like recall it again, here we have 44 times 2. Here we have negative 301 times 2. And here we have this number that is really fixed and constant. So we just want to make a circle like this. And I'm going to walk according to the circle. So suppose that you're working from here, like here. You are opposing this one here. And at this point, you have to take the negative value of this number. And that's why it becomes negative 698 kilojoule per mole. All right, and now we are coming. We are with the direction of this arrow in here. And that's why there is no need to reflect the sign. And actually, it remains as it is. But do not forget to multiply it by 2. And it becomes negative 301 multiplied by 2. And we didn't finish. Are we in the same direction? Yeah, we're still in the same direction. And this point here actually is the same direction as my circle, and it remains as it is. And that's why it becomes 44 times 2. At this point, if you use your calculator and just like add all of these constants together or these numbers together, you will end up with negative 1212 kilojoule per mole. And just like wait a second, we said that the question is asking me about the average bond energy. And since we're dealing with 2 moles from the beginning of the questions, and that's why you notice that we multiply by 2 here and here, then we're supposed to have 2 moles of BRF3 in here. However, this indicates that we have 6 bonds to be broken at this moment, which are 1, 2, 3, 4, 5, 6. And since you have this number, you have to take it here, 1, 2, 1, 2, and divide it over 6. And if you divide it over 6, it will equal 202 kilojoule per mole for each BRF bond.